Okay, so here we have the ACE testing bench that we'll use to verify use of meters, AC and DC, connecting components like resistant heaters, light bulbs, resistors, inductors and capacitors. And we have a different variable sources like a variable auto transformer. We have extra low voltage DC output, and we have the AC 3-wire system over here. So the first thing we'll do is we'll work on some DC labs here. We'll connect our auto transformer, the output of our auto transformer, over to our input of our rectifier. Now we can build a circuit from the output of our rectifier, a DC circuit. So we'll go straight to the meter. So we'll go negative to negative with our meter. We're expecting the output of up to about 120 volts. So we'll use the 150 volt meter for this lab. We'll go positive to positive. So we've now connected our voltmeter in parallel. And now what we want to do is we want to put something in the circuit, a load. So we'll put one of these heaters, a 600 watt cone heater. Again, we'll connect this in parallel. So we have positive to positive and negative to negative. Whoops, where did that go? Excuse me. Negative to negative. Okay, so now we're going to energize the circuit, and our auto transformer is at 0 right now. So we turn on the circuit and we'll adjust it up to half voltage, and we can see our needle on our voltmeter rising up here to 50% of our output now equals approximately 62 volts. And our heater, though it is giving off heat, would only be working to a quarter of its full potential right now. Now we'll crank it all the way up to its 100%, and you can see that is delivering maybe 130 volts, something around there. And now we can see that our heater is working to its full potential. It's getting quite warm there. All right, so that is the end of the DC lab, just to verify operation. So we'll move over now to our AC system. So on this side of the bench, we have some AC meters, voltmeters and amp meters, and we'll create a circuit with a light bulb here, and we'll verify current flow also. So we'll start with our circuit. We have a negative point. We'll just use 150 volts side because we're expecting a supply of 120 volts. So we'll go again positive to positive, negative to negative, and we'll go parallel with our voltmeter. We'll go in series with our amp meter, and we'll connect it to the 5 amp range because we have already done the math and we know that we're going to be within our 5 amp range. So out of one side is connected in series with our fancy light bulb up here, and we go all the way back. To finish off the circuit, we must go all the way back to our parallel point of our voltmeter. Okay, let's turn on the meter and see what we get. Okay, so we can see our voltmeter is showing us just over 120 volts. Our amp meter hasn't deflected too much, very low amount of current flowing in this bulb, but we can see our bulb is shining brightly there as it's receiving its full voltage. Now just to get a better look at our amp meters, what we're going to do is we're going to use a smaller resistance. This is much higher resistance, keeping the current low. So we're going to switch over. We're going to use a small resistance from our options here, just to verify that we are getting an accurate reading of our current flow. So we'll take this guy off here, and what we'll do is we'll build in a 10 ohm resistor, which is quite a lot less resistance than the light bulb will be containing, and we will see what that leaves us with there. Oh, we've maxed out our meter, so we've gone over full scale deflection. So what we'll do is we'll jump over to the higher meter, and we're going to need a longer cord here. So we'll substitute that cord. And here we go. So again, we're still at quite a lot of current there. So what I'm going to do to verify this, I'm going to drop down to a lower resistance and see where we fly now. You can see that
now we're getting some, yeah,
just come in
good,
much slower, like 5 times less. I expect that the current for that 10 ohm resistor would have been approximately 10 amps, which was pushing our meter to its limit. So there we go. We've verified the operation of the AC side of the circuit also.